Okay, so here is our example. So we've got this equation, and we want to test what kind of symmetry it has. So let's first test to see if it's symmetric with respect to the polar axis. So in order to do that, we're going to replace theta with the opposite of theta, or negative theta. So we're going to do r equals 3 sine of 2 times the opposite of theta, which equals 3 sine negative 2 theta, right? Okay. Now, what happens with this? So, if we look at this, so what happens with sine? Well, what happens when we take the negative of the angle? And we have a sine function. Okay, so let's say pi, or no, let's say pi over 2. So we get, let's say this is pi over 2, right? Well, at pi over 2, sine is going to be 1. What about negative pi over 2? Well, it's going to be negative 1. So if I put in, if I have 2 pi, and I put in the opposite, what I'm going to get is the opposite of this. So this is going to equal the negative of sine of 2 theta, or in other words, negative 3 sine 2 theta. So we don't end up with the same result. So since this changes the original equation, the test is not satisfied. However, returning to the original equation and replacing r with negative r, and theta with theta minus, pi minus theta, well, what do we see? Let's see what we get. Okay, so if we go back, okay, now let's replace r with negative r, and we're going to replace theta with pi minus theta. Okay, so let's do that. Okay, so what do we get? What do we get here? Well, we get negative r equals 3 sine, and this is going to be 2 pi minus 2 theta, right? And so now we can use the identity that comes with the sum of two angles. So we can use this, the identity, we're going to rewrite this as negative r equals 3 times, we're going to get oh, hold on a second. Hold on a second. I'm missing something here. Should have a sum. No, I should. No, that's right. That's right. Never mind. I'm thinking of something else. Looking here, though. So what do I got? I got 2 pi minus 2 theta. Or in other words, you can look at it negative 2 theta plus 2 pi. Well, if I add 2 pi, isn't that just the same as negative 2 theta? Because I'm just doing one revolution, right? So every 2 pi, I'm going to get the same thing. It's sine, right? So I know the period is 2 pi. So it's just going to, every 2 pi, it's going to give me the same thing. So this is going to be equal to 3 sine negative 2 theta. Okay, well, what did we say about negative 2 theta? Sine of negative 2 theta is the same as what? The negative 3, right? So negative r is equal to negative 3 sine 2 theta. Now, what do we get? Well, we multiply everything by negative 1, we get r equals 3 sine 2 theta. And so we get right back where we started from. So what does that tell us? Okay? This demonstrates that the graph is symmetric with respect to the polar axis. Okay, so remember what the guideline was. Okay, so if we go back to the guideline, it says that if you have a polar curve, and you've got the equation, it says the curve is symmetric about the polar axis if for every point r comma theta on the graph, the point r comma negative theta is also on the graph, which means that the graph is unchanged if you replace theta with negative theta. Now, if we did that in the first one, and we saw that we got negative r, or we got negative 3 times that, right? And then we said, well, let's replace negative r, right? Let's flip it, right? And then let's subtract pi. So rotate it by 180 degrees, which is the same thing, right? And we end up getting the result that we're looking for. Okay, so this is symmetric with respect to the polar axis. Okay, so again, the point is that when we did the original one, and we changed the original equation, the test wasn't satisfied. But again, if we go back to the original equation, we replace r with negative r, and replace theta with pi minus theta, then we get the same result. And this itself demonstrates that it is symmetric with respect to the the polar axis. Okay? And so that's it. So in the next one, we're going to do the same thing. We're going to test to see whether it's symmetric with respect to the pole. See you then.